All right, hey guys, well afternoon for me. I'm just in here filming for your sixth lab. As you know, we had some students with issues. They had to quarantine for a few weeks. I think it was almost half the class. So we decided to do the labs online, so most of you wouldn't get to miss it. So here it is, lab number 6. In this lab, it's a little different than other labs. There's no fume hoods. There's no really crazy chemical preparations. It's more of a lot of mini experiments and demonstrations. And we're going to be looking at mixtures, specifically colloids or suspensions, which we've done in class. And then we'll look at the properties of surfactants, what a surfactant might do to some mixtures or not mixtures in this case. So I'll be right back with the chemicals. I'll run over all the chemicals and then we'll start part A. All right, so as you can see, I have a lot of weird chemicals, a mixture of household ingredients, or, this is just soap. I have my sample bottles, water, glycerol, which is kind of a thick, oily substance, but you'll see the properties of that shortly. I have 2 chemicals here I'm going to use to make a precipitate, 7-Up, cyclohexane, some eggs, though I'll explain that in a little bit, milk, and then heavy cream, which I'll do a little experiment with that in a minute. So let me set up the first part of this experiment, the colloid or suspension section, and I'll be right back. Okay, so guys, I've mixed up all my solutions. Just a reminder here, I have glycerol, so I can see the layer of glycerol on the bottom there. All right, so water's on top, glycerol's on the bottom. Here I have my milk mixture. Here I have my lead 2 chloride precipitate. I added a little extra so you could really see it. Here I have my cyclohexane in water, cyclohexane on top, and water on bottom, and then my 7-Up. And I poured it fresh, and you can kind of see some bubbles coming up in there. So all of these have been poured, but none of them have been mixed. I might add a little bit more water to this one to get it up to the next level, but there you go. So what we're going to do very quickly, because I need to shake these up and then do my reaction, is look at something called the Tyndall effect. And here it is on the board here. The idea for this is if you took a light source, for example, a laser. So I have a laser pointer here. If I shined or pointed a laser through these solutions, the light needs to be absorbed by some sort of particle. So in a aqueous solution like NaCl, if I shined my laser here, it would hit the side of the glass and it would leave the other side of the glass, and we would not see that laser in that solution. I mean, realistically, because air is a homogeneous solution, we would see nothing. We would see the laser being turned on, hit the glass, nothing, and then come out the other side. But in a colloid or suspension, because there are suspended particles, when it hits this beaker, again, you won't see the laser in the middle. Air is a solution, so we shouldn't see the laser. But when it hits the colloid, and it notices that the light is absorbed, I guess I shouldn't say notice, but the light is absorbed by all the suspended particles, you will see the laser beam go through that solution. So the Tyndall effect is a very quick way, using a light source, to see if you have a solution or a colloid or suspension. So I'm going to dim the lights, and we're going to shine a laser through these and see what happens. Okay, and I might just add a little more water to the milk so they're all around the same level. So I'll be right back with the lights darkened, and before I shine the laser through these, I'm going to give them a shake to make sure everything is as mixed as possible. Okay, so I've shaken up all these solution. I've turned all the lights down. Let's see what happens. Now, first, this is just water. What does water look like when we shine a laser through it? Nothing really, right? Like, you can see the laser hitting the glass, but you don't see a line going through that solution. So this is what water would look like. You can see the laser on the left side and the right side, but that's about it. So let's look at the glycerol. See what happens here. All right, look at that. So with the glycerol, I can see the laser. I mean, you can almost perfectly see which suspended particles it's actually collecting on. So with the glycerol, I'm noticing that this is collecting on these droplets. What I've done is shaken this up, so the glycerol molecules are suspended. Pretty cool. All right, let's look at milk. You can see I've added a little bit more liquid to milk. Now, milk, this is the beauty of milk. Look at what the laser's doing. Not only is the laser kind of like, you know, shining through that solution, it's lighting up the whole solution. Look at that. There's so many particles here for the light to reflect or refract off of. So that's milk. Let's take PbCl2. So PbCl2, the same thing, but I'm getting a much more prominent light, you know, you can really see the light inside that suspension or colloid. Okay. Now, what about cyclohexane? Look what happened with the cyclohexane. It didn't mix. Okay. So this didn't form really any type of colloid because I'm still seeing two distinct layers. Okay, so again, this one, I'm not getting the Tyndall effect happening with anything because they did not mix. Okay, the 7-Up. Now this is an interesting one. 7-Up, let's shine my light through it. It's looking a lot like water, right? I don't see anything happen here. This is full of carbon dioxide, but carbon dioxide is a clear and colorless gas, and I'm not seeing any refraction here. This is apparently, you know, looking like a good homogeneous solution. But one interesting thing that I can do with 7-Up is shake it. And it's full of carbon dioxide. So now when I shake it up, you can see a little bit of the Tyndall effect with that carbon dioxide as it escapes that solution. So this is a really interesting phenomenon. As I let this sit, the Tyndall effect stops working. And this is something we talked about in the course. There's a way to break colloids or break suspensions. And I'm doing that by shaking this up. I'm allowing the molecules to do something. But it's really interesting because almost instantly the effect begins to fade. Pretty cool. All right, now I'll be right back. I'm going to talk about suspensions versus colloids, and there's only one part left of this experiment. So I just really want to take a minute and focus on these two particular chemicals, or mixtures, milk and the lead-2 chloride. I have let this sit for about 5 minutes, and you might be able to notice something happening with this compound in particular. Can you see the bottom of that? This isn't a beaker, but vial. In the bottom of that vial, I'm starting to get sediment. Sedimentation is happening. The milk still looks almost identical. Okay? So something is happening here which can help us really define the difference between a colloid and a suspension. Even as I'm talking, you can start to see this mixture is sedimenting, or there's sedimentation happening at the bottom. I have another beaker or vial of lead-2 chloride that I let sit for maybe 15 minutes, and you can see that right here. Look at what happens when I let this sit. Milk, as you guys know, when you go grocery shopping, I mean, milk stays like milk for weeks, or at least days. It's a stable colloid, and that's one of the definitions of a colloid. It should stay stable for long periods of time. So this has been 5 minutes, this has been maybe 15 minutes, and look at the difference. So I can do the Tyndall effect here and just see what's happening. Okay, I'm even in the one that I've let sit for 5 minutes, I can still see the light source going through. But in the one I let sit for a long time, it's not a mixture anymore. This would no longer be a colloid. And one way to really, define the difference between a colloid or a suspension is if you let it sit for 5, 10, 15 minutes. Will there be sedimentation on the bottom, or will it stay the same? And again, you can still kind of see the difference between the top of this one and the bottom of this one. Right, the bottom of this one, I can barely get my laser through it because there's so much solid, but at the top it becomes a little easier. And then milk, the same at the top, the same at the bottom. It's completely dispersed throughout this solution. So there might be a question in here about, milk versus lead 2 chloride, which is a solid, which is a colloid and which is a suspension. Okay, I'm moving on to the next part here, so I'll be right back once I have it set up. Okay, this is part B. There's kind of like a part B and a C, part C and a half kind of coming up here. I have the same mixtures here. I have water and cyclohexane, roughly the same amounts. Cyclohexane is on top, water is on bottom. I'm going to move into the next section in our course where we're looking at the properties of surfactants and what they could do for emulsions. Now, this is not an emulsion, this is not a solution or a homogeneous solution, this is a heterogeneous solution. So I'm going to see what happens when I add 2 different chemicals to these. I'm going to add soap to one of these, and I'm going to add an egg yolk to one of these. Now, full disclosure, I've done the egg yolk in the kitchen all the time when making some food, which I might explain a little later. I certainly have in class. I have not done the egg yolk with this, so this is truly an experiment. But I have done sparkling here, and we should see something happen with these heterogeneous solutions. So what I'm going to do off camera is I'm going to split these eggs. I'm going to separate them into egg whites and egg yolks, and I'll be right back. Okay, so I have my 2 solutions still. I gave them a little shake. I'm going to mix them with a bit of sparkling and a bit of an egg yolk, and we'll kind of do a little time lapse here. So just to prove to you that these will not mix from shaking, I'll give them a good shake. So shake, shake, shake. Nothing has been mixed with these yet, not one chemical. And what I'll do is I'll leave this here, and we'll just watch what happens over the next few minutes with this as kind of like a time lapse. So I'll be right back, but you guys just watch what's happening in these. Okay, so I've left them for long enough. I'm not going to wait forever, but according to my phone, that was only about a minute or so, and you can see that they're starting to separate out. So within, 60 seconds, they are beginning to separate. You can see the layer here and the layer here. I think I shook this one up a little bit more, but you can still see 2 distinct layers. So my goal now is to add some sparkling to the left one. I'll add some egg yolk to the right one, and we'll see what happens. And again, even now you can start to see them really begin to separate. So I'll add a pinch of these off camera, give them a shake, and we'll watch what happens. Sparkling has been added to this one. So this is hand soap or glass soap. You can see some on my fingers there. It's just soap. So it's a little white powder, and you can see the egg yolk added to this one. So a little sparkling, a little egg yolk. Now I'm going to give them a good shake. So let's start with the sparkling. I'll give them a good shake, and then we'll let them sit and watch again and see if some sort of emulsion will be formed. Now, one disclaimer about this one is sparkling is soap, which means it will kind of create some bubbles. That's unavoidable for soap. So let's see what happens with the egg yolk. This again might change the color because the egg yolk is yellow. But I don't care about some soap bubbles on top or the color being changed. I want to see what will happen now with these solutions if I let them sit over time. So I'll do kind of a similar thing here. I'll set up a little time lapse and we'll see what happens with these guys over time. So it's been a minute now. I'm going to let these go even a little longer here for science, but it's been, well, it's actually been a minute and 30 seconds, and I'm not really seeing the layers like I did before. Now again, soap will create bubbles on top, but the liquid layer, not the gas above it, but the liquid layer is still one solution. The egg yolk is even better, right? This looks like just one solution. Pretty impressive. So I'm going to put this aside and leave this for a little bit while longer and kind of show you something a little interesting with the rest of this experiment or rest of this lab. Okay, so guys, in this next part, I still have my emulsions here. I'm going to set them to the side, see what happens while I do an experiment with the egg white. Now, what I have is an egg white, just a little bit in a beaker. You can see it at the bottom. We're looking at maybe 5 milliliters or so. And in another experiment on the side, what I'm going to do is I'm going to take some of this cream that I got from Tim Hortons and put it in a jar like this, and I'm going to shake it up. I'll do that off camera because it's going to look really silly. So we'll set up some sort of time lapse here. Again, we'll leave our emulsions for a few minutes while we see what happens to this egg white. All right, so here we go. Okay, so that was a lot longer for me than it probably was for you. That was about 10 minutes. Now, keep in mind, I was using a stirring bar, not a whisk. If you were in the kitchen, you would use something like a whisk, and it would be, you could incorporate a lot more air into this. But look at the difference of what I started with compared to what I finished with. The volume alone has almost quadrupled. It's almost 20 milliliters of volume, but you'll notice it's mostly bubbles of air. Okay, so this is a type of colloid. Again, it might have been a little bit better if I had used a whisk or fork or something instead of a stir bar, but this is a type of emulsion between a liquid and air, which I won't say the name of. This, by the way, is not ethanol. Ignore the label. This was an egg white. Pretty cool. Okay, so this is a kitchen method people use to make something called a meringue. Pretty impressive. Now, as I was waiting for that to happen, I have my emulsions here. Still haven't broken. They're still emulsified. So the soap, the sparkling, and the egg white still have these, for the most part, completely mixed. And it's been about 10-15 minutes. You can still see the foam on the top, but again, that's typically from the soap. Now, something else I want to show you before I finish is off camera, I was doing something pretty interesting. I was shaking heavy cream. I've been talking a little bit in class about things like milk and the fact that milk is a good emulsion, or sorry, milk is a good colloid because it's a mixture of kind of like a liquid and milk fats. And one thing that maybe if you could learn one interesting thing today, if you ever wanted to make your own butter, you could take heavy cream, so it works best with something like whipping cream or cooking cream, heavy cream, and all you have to do is put it in a jar and shake that jar really fast. Now this is cream that I have not shaken. So this is cream straight from Tim Hortons, not shaken, you know, looks pretty normal. In this other one, I have shaken it a fair bit, and you can see it looks a little different, doesn't it? So I'll try to pour this one out. You can see it doesn't pour out as well because what I have left is actually butter. This is completely edible milk fat. Butter, literally butter. The stuff that's left over they call buttermilk. So you can make your own butter by just shaking this. Now there's a reason that this breaks the colloid. By shaking this so vigorously, I'm doing something to the particles to help break the colloid and turn it into a mixture of the solid and liquid. So you can see the liquid, but you can also see the solid. So I've done something, which is in your notes, to break this colloid. So that's it for today. That was maybe a bit longer than I thought, but we successfully made one type of colloid. This is a gas in a liquid medium. We've broken a colloid. We've emulsified two liquids using something called a surfactant, which I'll kind of let you guys read your notes about. And we also looked at the Tyndall effect. So guys, that's it for me. This is your last online lab for sure. We will be having lab 7 after this, your final lab, but that's it for me. So good luck with your questions, and I will see you soon.